Hello and welcome to the last session of lecture about bending members. In this section, we're doing an example on shear resistance. Example 6. What is the maximum live load shear that can be applied to this short jib crane? Assume that the steel is 350 Wt and the self-weight of the beam is negligible. The first step, as always, is finding section properties, and as you can see in this slide, now we want to find the shear of the member. As you know, in the clause 13.4.1.1, we have to find H over W. H over W is 225 over 7.4, which will be equal to X over square root of Fy. Therefore, X is equal to 568.83. Then we can see that H over W, which is 568.83 over square root of Fy, is lower than 1013 over square root of Fy. So, based on this clause, Fs, which is ultimate shear stress, will be 0.66 Fy. Therefore, the shear resistance is equal to phi times A times Fs, AW, 0.9. It's 247 times 7.4, and for Fs 0.66 times 350, so it will be 380 kilonewtons. If we check the tables in chapter 5, we can see that shear resistance of this member is 375 kilonewtons, which is close. Okay. Maximum live load. Okay. The shear force diagram for a cantilever with load P here is constant. And equal to the magnitude of applied point load. We know that VR should bigger or equal VF, which means the resistance shear should be bigger or equal to the factored shear, loading shear. So we know that VF is equal to PF here, which is equal to alpha P, and we know that alpha is 1.5 P because the factor of the live load is 1.5. And now we can find P. P is equal to VF over 1.5, and the maximum value for VF is VR. So VF cannot exceed VR, so I'm using 380 over 1.5, which is 253 kilonewtons. And this will be the maximum live load that can be applied to the crane. Thank you for listening to this session. If you have any question, you can either comment or email me.